Hello class, so today we're going to use a word problem and use that to describe how you can put that in an equation, create the table of values, find the ordered pair, and graph the same situation, just to show you how real life applications are done for proportional and non-proportional relationships. So the question is, suppose a town has a population of 5,000 residents, but that the population is decreasing by 200 people each year. Write and graph a linear equation to represent the population of the town in terms of the year. Now, before you even start writing equation or doing anything else, graphing, table, whatever, you need to define each part of the equation, which is what's your y, what's your x, what's your m, what's your b, because pretty soon you're about to write it in y equals mx plus b form. Okay, so you need to know these, what are your let statements for these, so you can clearly do it the right way. Now, my trick to do that is using my rate. It says it's decreasing by 200 people, people each year, people per year. So the residents are leaving town and people decreasing per year. So how do you write that as a fraction? People per year. When I do that, now I gotta set it up as y over x, because we always do y over x to find the constant of proportionality, or delta y over delta x to find the rate of change. When I write y over x, people came first, so people is represented by y, and year is represented by x. So this is my trick to figure out what's represented, what's my independent. My independent variable is x, which is the number of years. It doesn't matter how many people leave, years is not affected. But as time passes by, people leave, that affects the population. So y is your dependent variable that depends how long people live there. Okay, so let y, so I'm gonna use this information, so let y be the number of residents left, x is the number of years, so x be the number of years they lived there. Okay, since the time we started counting, or since the time we started taking the data. And our data here says that we started off taking the data when there were about 5,000 residents in the town. So whatever your starting data is, that is your initial value. Your initial value is always going to be your b, your y-intercept, which means that when x equal to 0, y is equal to b. That's your ordered pair. When you write an ordered pair, your first ordered pair will be 0, 5,000. It means that the 0th year, when you started taking data, there were 5,000 people. That's what that means, because my y is people and my x is the number of years. My 0th year, 5,000 people. Alright, so I need to do the rest, my rate of change. Now, this is how I look for my rate of change. Since it's decreasing, I'm going to use this information right here. The initial condition is 5,000 is b. It's decreasing, so it's a negative slope, and it's going down by 200 people each year. So negative 200 people every single year. Okay, so here's my fresh page for that. Y is your number of people left in town. X is the number of years. M is your rate of change, which is 200 people leaving town per year. And my B, which is my initial condition, you started off with 5,000 residents. So technically you're going to say, oh, my equation is y equals how many people left in town equals 5,000 people minus 200 people leaving every single year. So y equals 5,000 minus 200x. 200 is your rate, that's your m. this is your b. So if I have to write it as y equals mx plus b, it's on the other side, so please don't leave the sign behind, take it with you. So y equals negative 200x. Now 5,000 is plus 5,000 or positive 5,000, so when you switch it around, don't put it as minus 5,000. Minus came with the 200 in the front, so it's y equals negative 200x plus 5,000. That's the equation in the form y equals mx plus b. Y equals negative 200x plus 5,000. Now we're going to plug that into a table of values. So we're going to have our IPO chart, and in our IPO chart we're going to pick random values for x. I just chose 0th year, which is the first year we started recording, then the 5th year, then the 10th year, the 15th year, 20th year, 25th year. You can keep on going forever, how many ever years you want to take that data. But for census that they normally do, how many people are there in the town. So when I plugged it in for y equals negative 200x plus 5,000, remember, don't forget the negative. You plug those x values in there, plus 5,000, it'll give you the y, your output, which is your remaining population. And as you can see, the population is going down because of the negative rate of change. Alright, but look, something interesting happened. In the 25th year, there's nobody left in town. So you can't say in the 26th year there's somebody going to be in town. There's no negative people in town if that's the rate of change, unless people start coming back in. But that is not our situation. It wasn't mentioned anything of that sort happened. So we stop at 25 years because we figured there's nobody there. We take our x and y values and write the ordered pair. Now we're going to use this information and you're going to plug it into the graph. Now x represents the number of years, so the x-axis should be number of years. Y represents the number of people left in town, which is your population. So as you can see, y-axis is my population. I'm gonna zoom out so you can see better. And the x-axis is going to be the number of years. So I use 2 blocks for 5 years. So each interval is 2.5 years. Why did I use 5 years? Because I like to go up in 5, 10, 15, 20, 25, 30, 35, because from my IPO chart I figured out in 25 years there won't be anyone there. So I want to have a good representation of my data, and I want to spread it out instead of just piling them up here in this area. So my data is spread out evenly in my graph. Alright, so when I plot those data points, this is what I get. So the 0th year, the year when we start plotting, there are 5,000 people. 5th year going down to 4,000. 10th year there's only 3,000 people left. 15th there is 2,000. 20th year there's 1,000, and in the 25th year there's no one left. Okay, now since it's number of years, there is partial, like you can have months, and it's possible to have partial x values, like a fraction of an x value, which is part in months. So you can have 2.5 years, which is 2 years and 6 months. That's possible. So if it is possible to have partial data from your x values, it's okay to draw that line. Sorry, my line I didn't do the right thing. The line should go through those points. And also you need to know that it doesn't go through 0, 0, so it's a non-proportional relationship. And then this is when it is the 0th year, there are 5,000 people. In 25 years there's no one left in town. That's how you represent that word problem where with the population, where it's a decreasing population at a constant rate of change. Hope this helps you to apply proportional and non-proportional relationships in word problems related to real life applications. Alright, have a great day.